Hello, beautiful people. Welcome back to another banger. No, I'm just kidding. My husband dared me to say that. Okay, we're going to be going over lesson 3.2. This will go along with handout 3. Okay, so this will specifically help you with handout 3. So we're going to be graphing and writing equations of lines and slope intercept and standard form, graph and write equations of horizontal and vertical lines, determine the slope of a linear model, and understand its meaning in context. So just to review, that slope is equal to the rate of change. So the rate of change is how much is the y value changing for every 1 unit of x value changes. So as the y is changing and the x is changing, that's what we're looking at. It's y over x. The change in y values over the x values. Okay, so the slope will be the same for any 2 points selected on a line. So there is only one slope. Okay, so we were working on arithmetic sequence last week, and so you saw the u sub n is equal to the u sub n minus 1 plus the difference, the common difference. Well, now we can kind of see that we have the u sub 0. That's just your 0 term, so that's going to be your y-intercept. Okay, so very much related. And then your common difference, which is your d, okay, that is your slope. So we're going to see, we're going to write that there on the line right there. So u sub 0 and b is going to represent your y-intercept. Or you can say the 0 term and initial value. So if you see any of those things, those all mean the same thing. Okay, so that's when x is equal to 0. So when x is equal to 0, that will give you your y-intercept. And then d and m are going to represent your slope, or we call it the rate of change. And then, or we were calling it the common difference. All right, so we're going to go ahead and graph the equation of the line in slope-intercept form. We're going to graph y equals negative 3 halves x plus 3 and fill in the table of values. Okay, so we can see here that our slope is going to always be the number that's connected with the x. So in this case, it's negative 3 over 2. And our y-intercept is going to be the constant there, which is going to be plus 3, which we write it as 0, 3. Right? If it was negative, it would be 0, comma negative 3. But again, the y-intercept is when x is equal to 0, we get 3. So we can go ahead and just graph that already. I know I'm going to have my first point, my y-intercept at 3. It's where my line crosses the y-axis. And my slope is negative 3 over 2. So that means I'm going to go down 3 to the right 2. So rise over run. So down 3 to the right 2. And we can keep on going down 3 to the right 2. So just keep graphing, and I'm going to tell you guys in class, you always want to go in both directions. So to go both directions, you're going to go opposite. So you would go up 3 to the left 2. Always fill in the line so it can extend all the way out through your coordinate plane. Okay, so if we fill in the table of values, we can see that 0 was the y is 3. Our next term that we can see is 2 is going to be 0, 4 is negative 3, and 6 is going to be negative 6, and negative 2 comes out to positive 6. So you can see from here to here, we're subtracting 3, right? But remember that our slope is negative 3 over 2, so that means you're technically subtracting negative 3 over 2, which is just negative 1.5. So you're subtracting 1.5. So this would be 1.5. This would be negative 1.5. Let's see, negative 4.5. And then so this would be 4.5 as well. Okay. So here you're adding 1 and we're subtracting 1.5. So we get the slope of negative 3 over 2. because again, it's the change in y over change in x. All right, so now we have to write the equation of the graph line. So first thing I want to do is get the y-intercept. I can see my y-intercept is right there. It's going to be at 0. Pen is glitching. So 0, comma, -3. Okay. And to get the slope, you need to do your rise over run from one point to the next. So 1, 2, 3. 1, 2, 3, 4, 5, 6. All right, so my rise over run is 3 over 6, but I want to simplify that down, so I know that's going to be 1/2. So my slope is 1/2. So when you write your equation, it's y equals 1/2 x minus 3. And you're saying, well, we went from 3 over 6. Well, if you actually look, we do go 1 over 2. We go up 1 over 2. Up 1 over 2. You can see those points there. Okay? All right, so we're going to give the equation of the line in slope-intercept form that contains 3, 4, and 6, -1. So first we need to calculate the slope. So we need to use the slope formula, which is m is equal to y2 minus y1 over x2 minus x1. So you can plot those points and then calculate the slope, but to do it by hand, we're going to do it like this. So we label each point x1, y1. So that's just telling you that that's the first x, that's the first y. So this is x2, y2. That's telling you that's the second x and the second y. We're going to plug those in where they need to go. Like this is going to go here. This will go here. This will go here. And last one, this right here will go there. Okay, so just plug those in where they need to be. So we had -1 minus 4 over 6 minus 3. So we get -5 over 3 for our slope. Okay, so let's go ahead and graph this. So if we go 3, 4, okay, and then 6, -1. Again, your slope is -5 over 3, so you should be going down 5 to the right 3. I'm going to do it again. 1, 2, 3, 4, 5, and over 3. Okay, and I'm going to go the opposite direction from that first point. 1, 2, 3, 4, 5, and over 3. So I did end up plotting my y-intercept. So when it says solve for b value, I just want us to say the y-intercept, and again, the b is the y-intercept, is equal to 0, 9. Okay, so let's go ahead and make our equation. Y is equal to -5/3 x plus 9. Okay, so graphing lines in standard form. So we have the line 9x plus 16y is equal to 72. From standard form, you can automatically get your x-intercept and your y-intercept, and you can just plot those, and that's good. But here we do have the step to put it in slope-intercept form, so that means we're going to be solving for y. Solve for y. Okay, so when you're doing the when you're in standard form and you want the y-intercept, what I want you to think of is you're plugging in 0 for x. So you're plugging in, this would be 16 times 0, right? Plus 9x is equal to 72. Well, anything times 0 is just 0. So I want you to think of, okay, well, I'm just going to cross that off. So then, and I plugged in the wrong one. It's supposed to be 9 times 0. Sorry, it's very early. So I would cross this off. So then I would say, okay, 16y is equal to 72. Well, what does 16 times what gives me 72? And you can do 72 divided by 16. That will give you 4.5. So our y-intercept is going to be 4.5. Okay. Then you would do the same thing for your x-intercept. So you would plug in 0 for y. But you know that anything times 0 is just 0, so you could cross that off, and you would have 9x equals 72. Well, what times 9 gives me 72? Okay, 8. So that means my x is going to be equal to 8 and my y is equal to 0. X-intercept is when y is 0. Y-intercept is when x is 0. So we can plot those points. So first one is 8, 0 here. And then 0, 4.5. Just put that right in between the 4 and the 5. Okay, so before we connect, I do want to go ahead and solve it for y so you guys can see what the what our slope would be, because here you don't see the slope. You have to get it in slope-intercept form to see the slope. So 9x plus 16y is equal to 72. I'm going to subtract 9x from both sides. So I get 16y is equal to 72 minus 9x. I'm going to divide everything by 16. So y is equal to, we said that was 4.5. And that will just stay as is because, again, it's slope. So we can do rise over run from one point to the other. So the slope is negative 9 over 16. So y is equal to negative 9/16 times x plus 4.5. So from that first point, from the x-intercept, 8, 0, let's go ahead and go the opposite direction to get our third point for this line. So what I'm saying is, instead of going down 9 to the right 16, we're going to go up 9 to the left 16. So I'm going to go up 9 and then over 16, which I know is going to be at negative 8. So right there. And so now you can go ahead and connect those points there. For our line. Okay, and that's our line, which has our y-intercept, our x-intercept, and our third point, which we got just from using the slope. Okay, so again, we went, let me do it in a different color. We went up 9 and then 16. Okay. So, example 4, graph and write equations of horizontal and vertical lines. Okay, so y equals x. That is going to be a horizontal line. You're graphing a line that has all of the values are y is equal to 6. So I'm going to put my ruler at where y is equal to 6. Again, that is the vertical axis. Right here, the y-axis. So y is equal to 6. So my line is all of those points there. Okay, so this is x, this is y. I can literally plug in any point and it doesn't matter. All my y values will be 6. So I can plug in -1, -2, 0, 3, 4, does not matter. They're all going to be 6. Okay, so the slope of this line, remember, slope is the rate of change. So the change in y over the change in x. If I look at this table here, there is no change. It's 0, right? So 0 over whatever the change is here. Let's say it's 1. I look at these 2 points here at the bottom. This is going up by 1. This is going up by 0. 0 over 1 is just 0. So when you have a horizontal line, the slope is always going to equal 0. Okay, the x-intercept. So where does this line, y equals 6, cross the x-axis? It doesn't cross it at all. So this would be undefined. The y-intercept, right? Where does this line cross the y-axis? It's going to cross it at 6. So it's 0, 6. Okay, so now graph x is equal to -4. This is going to be always a vertical line through x is equal to -4. So we need to find where x is equal to -4 on the x-axis, which is right here. And we're going to go ahead and graph. My thing keeps getting... We're going to go ahead and graph that line. Oh my god, I need it right at 90. Okay. That is the line x is equal to -4. Sorry it took me so long. Okay, so we have our x and y table. That means all of the x values are -4. Doesn't matter what point I plug in. Okay, -2, -1, 0, 1, 2. Does not matter. All of the x values are going to be -4. So now to find our slope. So if I look at here, it's changing y, so I'm adding 1, but there's no change here. This is 0. So our slope would be 1 over 0. That is not 0. 1 over 0 does not equal 0. Okay? You cannot divide by 0. So this is an undefined. Vertical lines will always have an undefined slope. Horizontal lines will always have a slope of 0. Think about like if this was like a mountain or something, right? That mountain, you could not even go up that. Like that is straight up vertical, like up and down. You can't go up that. No way. Okay. So undefined. Our x-intercept, okay. Where does this cross the x-axis? Crosses at -4, 0. Our y-intercept, right? Does this cross the y-axis at all? No, it does not. So this is also undefined. Okay. So again, if it's a y, it's horizontal. If it's x, it's vertical. All right. So this example comes from the book, page 133. I don't want you guys to worry about having to go to the book, but I mean, you're always welcome to look at it. Okay. So Darren's car gets 20 miles per gallon of gasoline. He starts with a full tank of 16.4 gallons. As Darren drives, he watches the gas gauge to see how much gas he has left. So we need to look at the independent variable. Okay. And independent variable is basically the variable that's it's independent. It doesn't mean it's not changing based off of anything. So what's not changing is our distance. And we're doing distance in miles. So let's do that. And your independent variable is going to be your x. Okay. Our dependent variable, so what is changing, the amount of gas, is based upon how many miles you go. So that's why this would be that. And we're talking about in gallons. This will be your y value. So we have to look at the domain. So the domain is like what x values are we looking at? Well, we're talking about miles, right? You're going to start at 0 miles. You're not starting at -5 miles, -10 miles. You're starting at 0. Okay. And your x is going to be, well, how many miles can we go total? Well, to find how many you can go total, you need to do 20, which is how many miles per gallon he gets, times how much gallons of gas does he have? 16.4. And so that will give you the total. So you can go from 0 all the way to, this is going to equal 328. So our x values can go from 0 all the way to 328 miles. Okay. Our range is our y values. So again, this is the y-axis, this is the x-axis. We're talking about real life here. You can't have negative amount of gallons of gas. So you're going to start at 0. And how many gallons of gas can we have total? We already see it's going to be 16.4 gallons. Okay, so when you're doing domain and range, we write it as 0 is less than or equal to x, which is less than or equal to 328. My range, I can go from 0 to 328. That's it. That's how far my x values can go. My y values, same thing. It's telling you that the y values will be greater than 0, but less than 16.4 because we only have 16.4. We can't go more than that. Okay, but we can have less. 0, you can be at 0, but you can't go less than 0. That's what it's telling you. Okay, so we're going to go ahead and do the explicit formula. So again, explicit formula is when we write it as in y or f of x. F of x is equal to mx plus b. Right? Again, y is just the same thing as f of x. Think of it as a nickname, right? We're doing function notation. So we need our slope because we have our y-intercept, right? We know that we're starting at 16.4. Well, we need our slope. Well, I can find our slope just going based off of what the information we know. We know that he's getting 20 miles per gallon. So he's going to lose 1 gallon every 20 miles. So I'm going to kind of write that off to the side so you guys can see. So our slope is equal to 1 gallon over 20 miles, but since we're losing, it's going to be negative. or we can say negative 0.05. Okay, we're losing 1 gallon per 20 miles. That was what's given to us right here. Okay, so what our slope is going to be negative, so we'll have f of x is equal to negative 120 times x plus, what did we start with? We started with 16.4. Okay, so we want to know how much gas will be left in the tank after Darren drives 175 miles. So miles, again, is our x, so we're going to be plugging 175 in for x. So f of 175 is equal to negative 120 times 175 plus 16.4. I want you guys to give me the answer for that. So I'll be checking this in class right here. I want the answer. Okay, how far can he travel before his tank is empty? Well, the tank or the amount of gas is our y. So empty means we're plugging in 0. So we want to know when y is equal to 0. So again, y is just f of x. So 0 is equal to negative 1 over 20 times x plus 16.4. I want you guys to do that one as well. So solve that and tell me how far can he travel before his tank is empty. Okay, how far can he travel before he has less than 2 gallons remaining? Okay, so again, this is telling us we want to know when y is equal to 2. So 2 is equal to negative 120 times x plus 16.4. So how far can he travel before he has less than 2 gallons remaining? I want you guys to solve for that and give me that answer as well there. Okay. For the sketch, we know that our, let's say that this is 16. Okay. This is 16, right? We're going to be just kind of sketching what that should look like. Well, if that's 16, my y-intercept was 16.4, so I'm just going to say it's right there. And we know that this is going to be going down, right? So we need to also label our axes. So again, this is going to be the miles. And this is going to be gallons.